welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our today's lesson. The topic is force on a rectangular coil in magnetic field and if current is flowing in the coil. Students, you know that a current carrying wire behaves like a magnet, and if wire is in the form of rectangular coil and it is placed in the magnetic field of a magnet, then what happens? Look at this diagram. Here there are two poles of a magnet, north and south pole. There is magnetic field from north to south, and if a rectangular coil ABCD in which current is flowing, current I is flowing in this direction in this coil. Secondly, this coil is capable of turning about some central fixed point. There is an axis of rotation of the coil which are not shown here. Now students, when current flows through a wire, it becomes a magnet. Now I divide this rectangular coil in four segments. One is the length A to B carrying current I. Second is the length of the coil from B to C carrying same amount of current in downward direction. Third segment is C to D carrying current I from right to left. And fourth is the segment DA carrying current in upward direction. Now students, you know that when current carrying coil is placed in the magnetic field exerts force on it. And this force, along with the other factors, also depends on the direction which the coil or wire or the conductor is making with the magnetic field. In this case, from A to B, the segment of wire is parallel to the magnetic field. And similarly, from C to D, again the segment of coil is parallel to the magnetic field. Means current is flowing parallel to the magnetic field in these two sides of the coil. So angle is 0, and you know that sine of 0 is 0. No force exerts on these two sides of the coil due to magnetic field. Now come to the other two sides, AD and BC. In these two sides, the currents are flowing perpendicular to the magnetic field. Current is moving in upward direction, field is towards right. Current is moving in downward direction, field is towards right. So these two sides are such oriented that they are crossing the magnetic field or they are perpendicular to the magnetic field. So on these two sides there will be forces due to magnetic field. So here will be the direction of force on side BC according to Palm rule or Fleming's left hand rule. If we take the middle finger in the direction of current, first finger in the direction of magnetic field, then thumb points the direction of force that is directed outward, out of the screen. So this is the force F that is acting on the side BC. And similarly, a same force F acts on the side AD, but it is directed inward. So these two forces constitute a couple when a current carrying rectangular coil is placed in the magnetic field. Students, you know that the value of this force F depends upon these four things. How much is the current flowing in the coil? More is the current, more will be the force. What is the length of this side of the coil? Longer the coil, longer the conductor, more will be the force. And third thing is the strength of magnetic field. A stronger magnetic field exerts more force on the coil. And fourth thing is the angle. In this case, angle is 90 degree. Theta is 90 degree. The angle between length of the coil or length of the conductor or direction of the flowing of the current and magnetic field. Here direction of the current is downward, field is towards right, the angle is 90 degree. And you know that sine of 90 degree is equals to 1. So putting here sine of 90 equal to 1, we get this expression for force exerted by magnetic field on a rectangular coil placed in it. Students, this is the force that is acting on the right side, and same force is acting on the left side of the coil. These two forces are directed opposite, and since coil is capable of rotating about the central point, so these two forces constitute a couple, and as a result they produce rotation or turning effect in the coil. So when current carrying coil is placed in the magnetic field, it rotates, it turns about the central axis due to this magnetic force exerted by the magnetic field. So this is all about how the magnetic field exerts force on a rectangular coil that is placed in it, and the coil is capable of turning about a fixed point. I hope it is clear. Students, thank you for sparing your time to watch this short video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.